You're diving into one of the most famous fringe science topics in the water-splitting world. The Japanese tech university you are likely thinking of is the Tokyo University of Science, where researcher Hho.MASA conducted his experiments. What makes this different from standard HHO, Brown's gas, is the claim that the gas is fundamentally different, often called OH.MASA gas. 1. The core innovation: vibratory agitation. Unlike a standard electrolysis cell where the plate sits still in the water, OH.MASA's setup uses vibratory fins or plates that oscillate at a low frequency, typically around 50 to 100 Hz. The problem it solves: in normal electrolysis, tiny bubbles of hydrogen and oxygen cling to the electrodes. This creates a blanket of gas that acts as an insulator, forcing you to use more voltage to keep the reaction going. The vibration fix: the vibration shakes the bubbles off the plates the millisecond they form. This keeps the electrical resistance extremely low and prevents the plates from overheating. 2. The claim: liquid gas and cluster theory. This is where the science gets controversial. OH.MASA claimed that by using high-intensity vibration during the electrolysis process, the hydrogen and oxygen don't just mix as a gas, they form a new molecular structure: cluster formation. He proposed that the vibration forces the H_2 and O_2 into stable nanobubbles or clusters that are so tightly bound they stay together even when the gas is compressed. Safety: standard HHO is famously explosive and cannot be safely compressed into tanks, it will detonate. OH.MASA gas, however, has been shown in demonstrations to be compressible up to 200 bars, approx 3000 psi, without exploding. This is a massive deal if true, as it allows the gas to be stored like propane or natural gas. 3. The experiments: high-efficiency water splitting. OH.MASA's research attracted attention because his cells appeared to operate with an energy efficiency that defied standard Faraday expectations. Neutral electrolyte: he often used very low concentrations of electrolytes, like KOH, because the vibration compensated for the lower conductivity. Fuel mixing: he demonstrated that this gas could be mixed with heavy fuel oils or used to run standard internal combustion engines, with almost zero modifications and significantly reduced emissions. Does it actually work? From a peer-reviewed perspective, the vibration as a bubble remover part is 100% solid science. In fact, RMIT University in Australia recently published a study showing that using high-frequency sound waves, megahertz range, can increase hydrogen production by 14 times. However, the OH.MASA gas part, the claim that it is a new state of matter, or a liquid gas, remains in the realm of unconventional science. While his demonstrations of compressing the gas into scuba tanks are impressive, mainstream chemistry still struggles to explain how H_2 and O_2 can be compressed together without a catalyst or spark, causing them to revert to water. Why this matters for your DIY project. If you are building your own cell, like the one we discussed for your metal separation, adding a vibration motor, like a high-offset DC motor or a piezo transducer, to your electrodes could: 1. Stop clogging. It would help keep your bead membrane or electrodes clear of the rock powder and silt we talked about. 2. Lower your power bill. You'll need less voltage to move the same amount of current, because you won't have gas bubbles blocking the path. Are you thinking about trying to build a vibrating plate system for your ore separator? It might actually solve your silt blocking the membrane problem better than any other method.